Welcome to Midnight Hell. I am your host, Midnight. Today we will journey into the depths of our universe, a realm of infinite wonders. The universe is a vast expanse that goes beyond our imagination. It's a complex cosmic tapestry filled with mysteries that scientists have been trying to unravel for centuries. It's not just about the stars and galaxies we see, but also the unseen, the dark matter and dark energy that make up a considerable part of it. In this video we'll delve into the story of our expanding universe. We'll explore its birth, its early years, its constant expansion, and its intriguing composition. It's a story that begins about 13.8 billion years ago, stretches to the present, and extends into the future. So, are you ready to embark on this incredible journey, to traverse the cosmic seas and uncover the secrets of our universe? Ready to dive into the cosmic journey? Buckle up. Our journey begins at the very inception of the universe, the Big Bang. This wasn't an explosion in the conventional sense, but rather a rapid expansion of space itself. Picture a balloon inflating, but on an incomprehensibly massive scale. Everything that would later form galaxies, stars, and planets was contained in a single, infinitely dense point. Then, in an instant less than a blink of an eye, it expanded. The universe was born, a roiling, seething mass of energy and fundamental particles, far too hot for matter as we know it to exist. It was, in these moments, this cauldron of creation, that the first building blocks of the universe began to take shape. Within the first 3 minutes, the universe cooled just enough for protons and neutrons to come together, forming the light elements. Hydrogen, helium, and a dash of lithium emerged from this primordial soup, the first step towards the universe we recognize today. But it wasn't a smooth journey. The universe was a turbulent place, still too hot and dense for light to shine. It was a dark era, an epoch of cosmic fog, where photons of light were trapped, bouncing around in a dense sea of particles. Slowly but surely, the universe continued to expand and cool. Gradually the fog lifted. Atoms began to form as electrons combined with nuclei. Light, finally free to travel, began to fill the universe. The stage was set for the next phase of cosmic evolution. The universe was born, but it was far from the version we know today. The first stars and galaxies were yet to form, and the vast cosmic structures we see in our telescopes were still a distant future. But the seeds were sown in the heat and energy of the Big Bang, in the formation of the first atoms, in the lifting of the cosmic fog. From here on, the universe would continue to evolve, to change, to grow. But that, dear listeners, is a story for another time. For now, let's pause and marvel at the birth of everything we know. The universe was born, but it was far from the version we know today. After the Big Bang, the universe was a hot, dense soup of particles. Imagine a bustling, chaotic kitchen, where everything is sizzling and boiling over. That's a bit like the early universe. At this stage it was too hot, too intense for anything to really take form. But as with any good soup, things started to change as it cooled down. Now imagine a pot of soup cooling on a windowsill. As the universe expanded, it cooled, and this cooling process allowed for a significant event to occur: the formation of atoms. Hydrogen, helium, and small amounts of lithium, these were the first light elements to form, all within a span of 3 minutes. These ingredients, these atoms, were the building blocks that would eventually lead to the formation of stars, galaxies, and everything we know in our present universe. But before we got to stars and galaxies, there was a period known as the epoch of reionization. This is a fancy term that simply means the universe was becoming transparent. It's like the fog lifting on a chilly morning. This period, about 400 million years after the Big Bang, marked the birth of the first stars and galaxies. These celestial bodies emitted light which ionized the surrounding hydrogen, clearing the fog and allowing light to travel freely around the universe for the first time. These first stars and galaxies were like the pioneers of the cosmos, lighting the way for the universe as we know it today. They sparked a transformation, turning the universe from a soup of particles into a cosmic map filled with celestial bodies. The universe was taking shape, but its growth was far from over. Just like a child growing into an adult, the universe would continue to evolve, to expand, and to surprise us in ways we could never have imagined. But that's a story for another scene. Stay tuned as we continue our journey through the expanding universe. About 5 or 6 billion years after the Big Bang, a mysterious force came into play. This elusive power, known as dark energy, began to influence the cosmos in ways that scientists are still striving to understand. Dark energy, though invisible and intangible, is believed to constitute a significant portion of the universe. It's like the invisible hand behind the curtain, pulling the strings and orchestrating the cosmic ballet. One of its primary roles is accelerating the expansion of the universe. Yes, you heard it right, the universe is not just expanding, it's expanding at an ever-increasing rate. Imagine blowing up a balloon. As you blow more air into it, the balloon expands. Now imagine if the balloon started expanding on its own faster and faster with each passing moment. That's what dark energy is doing to our universe. It's the breath that's inflating the cosmic balloon, driving galaxies apart from each other at an accelerating pace. But how do we know all this? Well, it's a combination of theoretical physics and direct observations by astronomers. We've peered deep into the cosmos, observed distant galaxies, and noticed that they are moving away from us, and not just moving away but speeding away faster and faster. It's as if we're in the center of a cosmic explosion, a continuous Big Bang. And speaking of the Big Bang, it's crucial to note that our universe is approximately 13.8 billion years old. That's right, billion with a B. It's a mind-boggling number, isn't it? From a singularity, a point of infinite density and temperature, the universe has expanded over billions of years to reach its current size. And thanks to dark energy, this expansion isn't slowing down, it's speeding up. So, the universe continues to expand, but what does it consist of? Well, that's a question for the next scene, but here's a teaser. It's not just stars and galaxies. There's a lot more to the universe than meets the eye. Stay tuned as we delve deeper into the composition and shape of the universe. The universe is a complex mix of atoms, dark matter, and dark energy. When we look up at the night sky, we see a vast expanse that is as fascinating as it is mysterious. But what is the universe made of? Let's dive into the cosmic soup to find out. The universe is composed of atoms, dark matter, and dark energy. But here's the catch. Atoms, the stuff we and everything around us are made of, constitute only a small fraction of the universe. They make up a mere 4.6% of the universe's composition. The remaining bulk is dark matter and dark energy. Dark matter, which cannot be seen or detected directly, is estimated to make up about 27% of the universe. It's the elusive stuff that holds galaxies together. Then we have dark energy, accounting for about 68% of the universe. This mysterious force is believed to be the driver behind the universe's accelerating expansion. It's like the universe's own foot on the cosmic gas pedal. Now let's talk about the shape of the universe. The shape depends on a cosmic tug-of-war between the forces of expansion and gravity. If the universe's density is less than the critical density, it will expand forever, resulting in a universe that is flat or open. However, if the density is greater than the critical density, gravity will eventually halt the expansion, resulting in a closed or spherical universe. However, current observations suggest that the universe is flat, and it will continue to expand forever. But remember, our understanding of the universe is continually evolving, and new discoveries could change our perspective. With the universe expanding, its shape could be finite or infinite. What do you think? Our journey through the universe has been fascinating, hasn't it? We've delved into the birth of the universe, tracing its explosive start from the Big Bang. We've journeyed through time, witnessing the early universe as light elements formed and the universe cooled enough for atoms to appear. We've marveled at the formation of the first stars and galaxies, and pondered the enigmatic dark energy that accelerated the universe's expansion. We've navigated through the universe's composition, understanding that it's more than just atoms, but also dark matter and dark energy. We've contemplated the structure shaped by the gravitational pull of matter fluctuations, and the ongoing struggle between expansion and gravity that will ultimately determine the universe's shape. And in all this, we've realized that our universe is not just vast, but also expanding, and filled with intriguing mysteries yet to be solved. It's a fascinating journey, isn't it? And it's far from over. What are your thoughts on our expanding universe? Share your opinions in the comments below. This is Midnight, signing off from Midnight Hell. Until next time, keep exploring.